Thanks so much. This happens to be my 30th anniversary year of my first ECS publication in 1987, where the data, I'm not sure I could find it, but if I did, it would probably be on a 250K floppy disk about that big. But I remember walking that data down the stairs to the draftsman to draw the graphs that went into the paper. Now, I'll also say that the paper was submitted more than a year before it got published in 1987. So that also gives you a sense of the pace of science over the decades that I've seen it. Now, it's really a pleasure to be here. I have loved, given all those years of ECS affiliation, hearing people talk about the first society involved. And kudos to the society and all the great things, because I think of the scholars in the society as the leaders, but the society itself is really at the forefront of this. My talk today is really going to be about the culture, the deep culture of the counter norm, I learned the word from Brian, of counting as opposed to the norm of quantity. And I'm going to say I think of myself as not a counter, but it's insidious. And I've been, as a department chair, as an associate dean for research, and now as a director, somebody who's become more and more aware of counting. In fact, though, to give you a sense of how insidious it is, of course this year in July when the University of Washington Clean Energy Institute, or Clean Energy Science and Engineering, moved into the top 20 of the global rankings for that subject area, I immediately let everybody know. But when you look beneath it, it's based on impact factors. It's based on how many papers our people publish, which impact factors, what are the citation indices. That is a measure of something, but it is not the measure of everything about what we do, because our mission is to bend the curve on carbon. And we need to be doing what we can to go faster, because the students I teach, in 20 years from now, when they're my age, and I'm being generous with my age when I say that, they are going to be in the world that they create, help us create. And I hope it's a world that is a trajectory for carbon and climate that is a good one. So let me talk about some of the trends, some of the things, and the ways I hope ECS thinks about taking this initiative and meshing it with the world I exist in as an academician. And let's talk about things you've already seen today. Megatrend one is that funders are asking for new measures of research impact. I think we saw with Ashley that the Gates Foundation is looking for impact. And so here I put language that came out of the National Science Foundation. This was National Science Board approved in 2013 in the grant program guide. A list, this is how you justify that you're a high qualified investigator in your resume, your biosketch. You're supposed to provide a list of up to 5. In 2012, it was publications, scratched that and put it products, most closely related to the proposed project, and up to 5 other significant scratch publications, products, whether or not related to the proposed project. And so this is a license to think differently about how we count and what we measure. We have to just be able to document that what we're doing is impactful. This is the license given to us by the funder. Now, most of us our NSF in this society have had National Science Foundation funding, but of course, this is a trend I think we saw from Ashley and from others to really try starting to think about this. And this does not tell us what that product is. It has to be archived and long-lived, but it's not telling us what it is. So what are some of the things it could be? Could be shared data, could be open source software, other research projects, processes, if appropriately archived and accessible. And I think that we just heard how NIH is trying to create the culture of doing this and what it means to be appropriately done. But this is our license as scholars to think creatively about what is a research product that is impactful. Now, as a society, there are other organizations that are out there trying to create products that we can recognize in our current culture of having publications with DOIs and whatnot, like Nature Publishing Group putting out the journal Scientific Data. This is a paper that we all recognize in our current climate of academia, but underneath it is long-lived archived data. And the paper is really about what is this data set, how do you use it? And I think ECS is a society that can do this extremely well in our domains of scholarship. What are the metadata data that we need to make this useful for our scholars? How do we put that data together, curate it in a way that we accelerate progress? Because for what I do, I want to be going twice as fast so that in 20 years from now, we're creating that world that we want to create. So that's one mega trend. ECS can do this through its publications and through partners with Dryad, or my university has something called ResearchWorks, which qualifies as a long-lived archive product through the library system. All right, so what's mega trend 2? I'm going to say it's exponential growth and impact of open source software. These are tools that if you're in a big science area, like astronomy, where there might be a few telescopes in the world that can measure what it is you're trying to measure, you have to share the data. You have to create a community, the data and the scientific tools for analyzing it. Your field doesn't move forward if things aren't open, transparent, and available to everybody else. And so whether it's astronomy, genomics, I think computer science has been great at this, some big biology projects, high energy and nuclear physics. These are really areas where you have to have shared, and they've created cultures around valuing these kind of data sets and the software that is used to analyze and create it. Now, I think that there are some areas in a more bench scale ECS field. I mean, many of us have used ImageJ from NIH, an open source piece of software to analyze images you create. It was created for certain kinds of images, but we all use it. But I think that there's a great example at my own university that many of us have gone to synchrotrons and used the DOE facilities at Brookhaven, at Argonne National Labs, and around the world. There's a handful of these facilities, so it does fit in with the high energy physics sort of community stuff. But within there, there's something called the FEF project, which my colleague John Rear in UW Physics did. And he's a theoretical physicist who is looking at how do we do ab initio calculations of multi-body interactions of shell and core electrons with X-rays. And he came up with a great theory with no adjustable parameters, and he turned it into software. That software now is embedded in every single way that people analyze synchrotron data. And that was huge for the impact of his scholarship. That software now, there's all kinds of packages. Buried in the middle of it is FEF, F-E-F-F. And this is FEF9 is what they have for download now. And it's created a community of collaborators, of software tools that are out there. I think that in ECS, we are comfortable with open source in some ways. National Instruments had an incentive, a commercial incentive, to create a community of people that made virtual instruments that we could use on our machines in our laboratories at the bench scale. They had a commercial reason to do that. But if we create community around the ECS goals and tools and whatnot, we can also create a community of shared software that moves our community forward. And again, it's all about accelerating. So FEF has an open community. LabVIEW VIs, we can share them and make our instruments do more things. ECS could have all the kinds of analysis tools, and that's going to be part of what we're going to do at the Hack Day. By the way, the Hack Day is using OSF as its framework. It has a DOI, so the participants are going to have an object identifier that says, I was there, I was doing something. And if software products come out of that are valuable to the community, people will have a citable, traceable set of contributors to that. Okay, this, I'm not going to necessarily, none of the journals I'm talking about are endorsements of them, but they're models for ECS to think about. And so, for instance, when I was talking to people, how do we get credit for the people today that want are in promotion and tenures and they're going up. Well, we can create, again, just like scientific data was a paper linked to a data set, we can create papers linked to the software that we create. Journal of Open Source Software is a community run. I love watching the open reviewing. Ashley talked about open reviewing at the Gates Foundation process, and it is such a positive community building rather than some of the things that you see in the private world of reviewing. You know, people review and they say, you know, they're trying to help them make a better piece of software. And then you get a publication with a DOI, Journal of Open Source Software. ECS can do this. I put the business model there because this is off their website. It doesn't have to be expensive to have a community-driven set of reviewing processes. Okay, so what's the last mega trend? It is that at the end of the day, ECS is about the people in ECS and creating opportunities for the people. That's how I view my job as a professor. And all the things we're talking about, open data, open access, gives people tools that they can use out in fast-growing parts of the economy. And so at UW, we have done a lot to cultivate domain science expertise, plus some of the data science tools, open skills to go and work. For instance, my student Matt back there is one of the first cohort of the NSF-funded Big Data IGERT that's run through our eScience Institute. And so he's getting a PhD in chemical engineering with a transcripted advanced data science addition to his PhD. And in Seattle, pretty much, if you can program in R, SQL, and Python, you'll always have a job. And so that is just, it's just how it is. It is a fast-growing software publishing and information sciences are much faster growing in the STEM fields than professional scientific and technical services, which is next fast growing. And then things like manufacturing, which we traditionally do. By the way, I'm citing Bureau of Labor Statistics numbers for their 10-year projections. Manufacturing is shrinking. So we need to make the knowledge of our community more available through open data, open software, and give the people that we're training skills for the modern data-centric economy. So we've already heard ECS has joined the Center for Open Science. We're using some of those tools. And these are tools that really give us, as a community, the opportunity to build the community. I think we heard lots about it already this morning. So with that, I'll thank you, and we can conclude.